Now here's another example where we have a identity and we are asked to verify this identity, but we've got a little bit of an imbalance right here. And the way that I like to think about verifying an identity is that if I can at all do so, I'm going to choose to simplify the most complicated looking side of the equation in order to obtain what's on the other side of the equation. So right here I can see that in this particular situation on the right hand side I've got a lot going on. I've got sine squared x times tangent squared x plus sine squared x, and on the left hand side I only have tangent squared x. So I'm going to start on the right. Now, a lot of people will also look at this and say, well, okay, so I'm going to have to rewrite all of this in terms of sine and cosine, and that could make things really, really complicated. So, one thing that I can uh, tell you right now is if you've got a lot of terms on one side, you got a lot going on one side, but not much on the other, probably the very first thing you might want to do before you start doing any of these trigonometric identities is do the algebra first. If you can all use an algebraic type of substitution in order to simplify an expression, in order to factor, multiply, add, subtract, multiply, or anything else, do the algebra first. And so you think, well, what could I do that's algebraic on this left-hand side? Well, I'll tell you one thing that I see right away is that I do have tangent squared x on the left, and I don't want to change anything that has tangent squared x over here on the right if I can avoid it. So let's see what we can do. Sine squared x is a factor to both of the terms over here on the right-hand side. So let's try factoring it out. So we would have sine squared x multiplied by tangent squared x, and by the distributive property that would be plus 1. Well, okay, so that seems like it might be something right there. Is there anything that we can say? Well, what is tangent squared x? Right now I can see that just by that one algebraic manipulation I do have an identity. So next, I'm going to look for any trig identity that I can use, and there is one here. If you'll note, 1 plus tangent squared x is secant squared x. So on the right-hand side, I've got the square of the tangent of x, and that will be equal to the square of the sine of x, times the square of the secant of x. Okay, well there is some connections. There's something definitely going on right here. But okay, so what could I do? Would I replace the secant? Well, no, I just came from there. So now what? Well, tangent of x and sine of x are related by a ratio identity. Is that a possibility here? I say yeah, right? Here's another identity that secant squared x would be the same thing as cosine x, 1 over cosine of x, right? So let's replace that. What do we get? Tangent squared x is in fact the same thing as the square of sine of x times 1 over cosine of x. Well, cosine squared x in this case. When we put that together right over here on the right-hand side, look at what happens. Tangent squared x is the same thing as sine squared x over cosine squared x. And yeah, sine of x over cosine of x is tangent of x. Therefore, the square of the tangent of x over the square of the cosine of x would be the same thing as the square of the tangent of x. This verifies our identity, and so, yeah, we're done. There it is. That's our identity. We've just verified it. Okay, more examples to come.